1, 2, and 3. Well, I'd like to start off the day by first off introducing myself. Hello, my name is Lance Zurich, and I'm the product manager for the Fischertechnik division over here at Studica. And today I'm going to provide you with an overview of the Fischertechnik Education Robotic Competition Set. Now, this set is designed to provide students with the tools and background needed for participating in robotic competitions. This is whether they're at the local level or even large-scale national and international competitions, such as things like the RoboCup Junior. Now, more than just that, though, this set was also designed to enable educators to provide students with a project-based, standards-focused curriculum program involving inquiry, design, and problem solving. Now, the curriculum for this set, just like the curriculum for Fischertechnik's two other curriculum-focused project-based sets, which are called STEM Prep 2.0 and STEM Engineering, and they are the focus of their own webinar presentation if you're so inclined. The curriculum for all of these sets was created especially for Fischertechnik and Studica by noted educator and STEM expert Tom White. So, to start things off, the magic question might be, so what is STEM? Well, at this point, most educators are well aware that the term STEM is an acronym which stands for Science, Technology, Engineering, and Mathematics. Now, if you're involved in any aspect of education, you probably can't open your email box without seeing STEM highlighted in the subject line of at least one of your daily messages, and you certainly can't read an educational journal or visit an educational conference without being bombarded by references to STEM. Now, the reason for this is really pretty simple. To quote the bipartisan Congressional STEM Education Caucus in their report on the importance of STEM education is necessary because it helps provide the scientists and engineers needed for future development. It provides the future workforce with the skills required of a high-tech world, and it builds the foundation for scientifically literate voters and citizens. Now, as such, STEM education could really be considered a matter of national security. On every level, the world around us is changing at a frantic pace. STEM education, it could be argued, enables us both as individuals and as a nation to understand and keep up with these rapid changes in technology, changes which in turn are altering the demands and scope of industry. And obviously, if we as a nation are to keep our stature and position on the world stage, this requires us to keep pace with the rapid developments which are occurring all around the globe, where countries such as China and India are making major investments in state-of-the-art infrastructure. And while all of that is well and good, and we should of course all strive to be good citizens, many students might also ask, so what's in it for me? Why do I want to study engineering? Why do I want to study coding, or fill in the blank? So let's consider what it means on the individual level. Well, first off, a few years back, the United States Department of Commerce released a set of projections for the decade leading up to 2018. Now, these projections indicated that STEM occupations would expect to grow by 17% compared with just 9.8% growth for all other occupations. Now, in March of 2017, the Office of the Chief Economist released a STEM Jobs 2017 update, which took a look at how these numbers were playing out up until the end of the year 2015, with 3 years still left in the initial projection. Now, what they found at that point was that while the projected STEM growth, once again up till the end of 2015, was a bit less than they expected to reach in total by 2018, and by that I mean that it would reach 14% instead of the full 17%, which it still had 3 years to go. The actual growth for non-STEM jobs, which they had recorded at that point, which once again was expected to eventually reach 9.8%, was instead only a fraction of that. Only 1.7%. A very stark difference. Now, here's the statistic that I like to share that should give anyone entering the job market of the future pause. And this comes from J.D. Chesloff in his Education Week article from March of 2013. To quote Mr. Chesloff, across the country, across all occupations, there are 3.6 people for every one job. In STEM fields, there is one person for every 1.9 jobs. Employers can't find the talent to fill these jobs, which is even more surprising, considering the U.S. Census Bureau recently reported that the median salary for engineering majors was the highest of any profession. End quote. So as Chesloff goes on in his article to state, quote, supply is low and demand is high. there is a mismatch between projected future jobs requiring STEM skills and the projected supply of qualified workers to fill them, end quote. Well, going back to the STEM Jobs 2017 update released by the U.S. Department of Commerce, which I referenced before, here are 3 key points mentioned in this report that are well worth keeping in mind when considering the importance of STEM education to the worker. Key point number 1, STEM workers command higher wages, earning, on average, 29% more than their non-STEM counterparts in 2015. Key point number 2 relates to the fact that many graduates with STEM skills may not always end up in what are strictly considered to be classic STEM jobs. These would be things, of course, such as scientists or engineers. Quoting the report, STEM degree holders enjoy higher earnings regardless of whether they work in STEM or non-STEM occupations, end quote. Excuse me a second. There was also a video which I saw recently on YouTube, and it was posted by the Women's Forum for the Economy and Society, the title of which really summed up things nicely, I think, and that title was, quote, "Every company is a tech company," end quote. Essentially, what students want to keep in mind is that whatever a company makes, whatever a company sells, or whatever service a company performs, at some point, STEM skills are required to help that company fulfill their mission. Going back to the key points, though, key point number 3 relates to job growth. Quote, employees in STEM occupations grew much faster than employment in non-STEM occupations over the last decade, and by this means 24.4% versus 4%, respectively. And STEM occupations are projected to continue to grow by 8.9% from 2014 to 2024, compared to just 6.4% growth for non-STEM occupations, end quote. Now, the trick for educators is to find methods for getting students involved with STEM, and in particular, the most highly in-demand technology-focused skill areas. These are things such as engineering and coding, to get students involved in a way that engages their students' interest and creativity, and while at the same time developing the work habits, the way of approaching problems, and the skills that they will need to draw on as they move forward in their careers, both their academic careers and in their working lives. Now, most experts agree that one of the most effective methods for teaching STEM is by providing exercises where certain results are going to occur, and the students have to discover why those results occurred, or where students have to find a way to achieve a specific outcome. The way they do this is through experimentation, through research, and through trial and error activities. In short, they find the answers to these questions through the use of hands-on, project-based learning. And this brings us to the focus of this webinar, which is the Fischertechnik robotic competition set. Now, this set is one of 3 different standards-focused, project-based sets currently available from Fischertechnik Education. The other 2 sets, STEM Prep 2.0 and STEM Engineering, are the subject of another webinar presentation, so we of course won't delve into those too deeply here, and instead we're going to focus on the robotic competition set. In any case, though, each of these 3 sets have been designed to provide a guided, project-based learning experience complete with detailed curriculum, all using the unique Fischertechnik building system. Which may beg the question, so what is Fischertechnik? Well, just to provide you with a little bit of background, Fischertechnik is a flexible and innovative construction system. Now, unlike other popular construction sets that are designed to simply stack, Fischertechnik was created with more of an engineering mindset. And what I mean by that is that the core building block in the Fischertechnik system is unique, and that it allows attachment from all 6 sides, and thus it allows for almost limitless design possibilities. Many of the parts slide together to lock in place, and the hundreds of different parts available also help to address very specific design needs. Fischertechnik was created back in 1964 by German inventor Arthur Fischer, who's known for countless innovations used in the construction and the automotive industries. Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fischertechnik, Mr. Fischer was the inventor of synchronized flash photography back in 1949, as well as the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fischer Group, employs thousands of individuals worldwide, providing many variations of fastening devices used in building construction, as well as various components used in the automotive industry. And they also provide consulting services in regards to various manufacturing processes. I would also like to mention that Fischertechnik was the very first construction set to offer students the ability to build and program their own robots, and that was using the original pre-Macintosh era Apple computers. Now, almost since its inception, Fischertechnik has been used by middle schools, high schools, colleges, and universities all around the globe to explore STEM-related subjects. And these would be, of course, things like robotics, renewable energy, mechanics, optics, physics, pneumatics, and much more. Fischertechnik has also been used by numerous companies, and these are companies like Porsche, Daimler, Chrysler, and BMW, just to name drop a few, for industrial simulation and training purposes. Now, in addition to this, over the last few years, Fischertechnik's line of pre-assembled simulation models have found wide adoption for demonstrating and exploring the world of IoT, which is, of course, also known as the Internet of Things, where industrial processes can be monitored and controlled from the cloud. Now, as such, more than just being something students may only use for a year or two in their development, Fischertechnik is designed so that students can grow with it. As students progress through their academic careers, they can also progress through the levels of Fischertechnik education solutions which are available. Now, the Fischertechnik robotic competition set is designed to provide educators with a clear and detailed pathway for exploring the subjects of robotics and coding through the focus of learning on how to create mobile robotic models for use in a competition setting. The set is designed for use by teams of 2 to up to 4 students at one time. It contains 670 components, all of which come packed in a sturdy plastic Gratnell storage box. The set is designed to provide all of the materials that you will need, and by that we mean both the physical and the instructional materials, to enable teachers to offer a complete, standards-aligned, curriculum-based, competition-focused class or after-school activity. Now, as I mentioned before, the curriculum used with the robotic competition set was created especially for Fischertechnik by a man named Tom White. Now, Tom is a noted educator. He's been involved in STEM education since the 1970s, and he's known for designing programs for educational institutions and for industry. In fact, as an expert in hardware and software integration, Tom was pivotal in introducing CAD, CAM, control systems, digital control, additive manufacturing, and other such topics to the classroom. Now, currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. Now, this is not the first time that Tom White has created curriculum around Fischertechnik. Besides also being the creator of the curriculum used in our elementary-focused Introduction to STEM series, as well as the long-form curriculum used in the Fischertechnik STEM Prep and STEM Engineering sets designed for use in middle and high school and in higher education. Besides this, Tom has also incorporated Fischertechnik in many of the educational programs that he has designed over the years. Now, Tom has told me that he believes that Fischertechnik is the ideal construction set for any engineering-based curriculum program, and he's given several reasons for this. First off, he really likes that the materials can be used and reused. Things that are built can be taken apart and reassembled into something completely different. And he likes the versatility of Fischertechnik and the fact that it offers so much more economy than purchasing an expensive piece of equipment, for example, something like, let's say, a robotic arm, which might only be used for a few experiments or projects and then put on a shelf to gather dust until the next semester's class. He also appreciates that the Fischertechnik system, with its wide assortment of very specific mechanical and structural parts and components, offers almost limitless creative opportunities for engineering students. And just to break in for a second, yes, seeing the question from Brian, will there be a recording of this webinar available afterwards? You betcha. We're actually recording it right now, so you will see a link for that very shortly after this is done. Moving right along. So when Tom White designed the curriculum for our 3 project-based learning sets, he had several goals in mind. First, based upon his observation that various types of teachers have different strong points. For example, he sees his own strong point as being the creation of curriculum such as this, more so than, let's say, conducting a lecture. With this in mind, he focused on creating detailed curriculum that would provide a broad foundation of tools for all types of teachers to be successful in providing this class, and so that they could instead focus on the needs of the students. Now, he made sure to include a special tutorial section at the beginning, which will help familiarize new users with how the unique Fischertechnik system works. And he made sure that each section of the curriculum clearly spells out how everything will be addressed in that specific unit. In short, he designed the curriculum and selected the components included in each set to essentially act as a turnkey solution that would provide everything teachers should need to deliver the material effectively in one place. Again, the curriculum was designed to provide a clear roadmap for both the teachers and the students. The goal was also to enable teachers to provide students with engaging curriculum-based projects that had an authentic objective in solving real-world problems and which contain embedded academics. Now, the detailed curriculum for this set, if followed, provides the basis for what could be a standalone project-based robotics class, or if you wish, an ongoing after-school activity. Now, under this project-focused model, students are told upfront what they are going to need to learn and understand. They are given a real-world scenario where they are going to take on the role of a professional working on a team, which has been presented with a design challenge that they must devise a solution to, and they are then provided with different tools and pathways to help them achieve this goal. Now, among other things, students must perform research, and that's going to be research both inside and outside of class. And they will learn the documentation process. For example, things like creating a design brief, maintaining a digital engineering journal, and so on. And they're going to collect data. They're going to learn firsthand how data acquisition works. They're going to learn how to process data, how to put the data into graphs and other formats, and so on. Students are given a technical literacy task driven by the project. Fulfilling this task will require them to gain the knowledge and the tools needed to address it through research and exploration. Students will perform a series of specially designed enabling activities through which they will acquire the necessary science, math, and tech-based skills. They're going to devise solutions to their tasks and create prototypes, of course, using the advanced Fischertechnik modeling system. Students will then create and install programs needed to control their prototypes. They're going to document every step of the entire project. And at the conclusion of each project unit, each group of students will be required to formally present their findings, including a demonstration of the prototype in action. Now, the curriculum itself comes in the form of a 576-page downloadable PDF document. This document, which we will explore shortly, contains detailed academic material for use in a classroom or after-school setting, as well as full-color step-by-step assembly instructions for building a series of 20 different models. Now, the assembly instructions are included both as part of the PDF documentation and also in a physical printed form inside of each set. Now, as many educators and students may be new to the Fischertechnik building system, once again, the curriculum PDF also includes a helpful tutorial section at the very beginning to help both teachers and students to quickly get up to speed with using the system. This section covers such areas as how to identify the various parts used, learn how they fit together, and even involves the assembly of a very basic model. The curriculum itself is divided into 4 main project themes. The project's themes, or units, focus on competitions, programming, sensing and vision systems, and mobile robotics. The curriculum as a whole is designed to provide enough academic material to cover approximately 70 hours. Now, according to program creator Tom White, there is room here for educators to be flexible with this. As he pointed out to me recently, a teacher could choose to leave some things out and use this to fill approximately half a semester, assuming a daily class period of 50 minutes, or they could add some hours of experimentation to easily bring it up to 90 hours or so if they chose to. Now, during the course of the 4 project themes, various activities are also addressed, and various subjects touched upon, and this will include things like sketching, schematics, Ohm's law and power, introduction to using the RoboPro software, which is the programming software used with Fischertechnik systems, introduction to using the TXT controller, which of course acts as the controller for any of the Fischertechnik robots that you'll be building, working with flowcharts, open loop programming, closed loop programming, digital branching, edge triggered versus level triggered, logic gates, combinational logic, analog branching, variables, data, sensors such as the digital switch and digital phototransistor, as well as the digital trail follower, analog sensors including the NTC resistor, Photocell LDR, the color sensor, the ultrasonic distance sensor. An introduction to using the camera attachment, using the camera to detect motion, doing color detection, creating a ball finder, which uses the camera as a swiveling eye to see where the ball is at, working with the line tool, the encoder motors, and building the control panel. Now, I would also like to point out that the curriculum for the Fischertechnik robotic competition set has also been designed to address some of the most widely recognized academic standards currently in place in the United States. Now, this includes the college and career readiness standards for math, science, reading, and writing, the NSES content standards, standards for technological literacy, ISTE Foundation standards, and the next generation science standards. At this point, let's look briefly at some of the actual physical materials included in the robotics competition set. Now, as I mentioned previously, each set contains 670 parts and components, and this includes a license of RoboPro graphic programming software, which is for Windows-based computers, the powerful and compact Robotics TXT controller, which has a full-color touchscreen, Bluetooth and Wi-Fi connectivity, programmable sounds, and much, much more, and also a Fischertechnik rechargeable battery pack and charging unit for powering all of the models. Among the specialized components included is a gyro sensor, which is only available with this set, 2 encoder motors, a USB camera attachment for building robots with vision system capabilities, as I touched on before, a phototransistor, an XS motor, 2 push-button switches, a color sensor, an NTC resistor, 2 LEDs, 3 ultrasonic distance sensors, an IR trail sensor, a photoresistor, a reed contact, and of course, hundreds of other parts of various types, all of which again come packed in a sturdy Gratnell's storage box. Now, the set also includes printed materials such as the full-color 74-page pictorial assembly manual with instructions for building 7 different stationary and 13 different mobile robotic models, for a total of 20 models in all. Also included is a printed sample track and a side fence. Now, essentially, even if one chose to ignore the standards-based curriculum, you could still view this as the ultimate Fischertechnik mobile robotics set. The contents of this one box will allow you to build all of the models found in both the Fischertechnik Robotics TXT Advanced set and the Robo TXT Explorer set. Again, everything students will need to build all 20 robotic models is included in this box. That means the programming software again, the controller, the power supply, and of course, every part they're going to need. Now, as I mentioned several times that this set will allow you to build 20 different robotic models, let's take a quick look at those models. Now, again, please note that these are, of course, not the only models that you can build with this set. In fact, each of the 4 project themes in the curriculum will really only use these models as at best a reference, and instead will require students to design and build their own original models to help them solve the core problem that's put forth in each unit. Now, with that all being said, this one set will still include all of the parts required as well as the detailed step-by-step instructions for building each of these models that I'm about to show you, which can be studied and experimented with on their own or used to help students to explore and understand the concepts that they will draw upon for their own unique projects. So we'll just take a quick look. You have things like the automated ventilating fan, the temperature control robot, the automated hand dryer, the traffic light simulation, automated parking barrier, a swiveling security camera with an alarm, cameraman, the basic mobile robot, hindrance detector, a hindrance detector with a camera, a trail searcher, a detection robot, a soccer robot with movement control, and a variation where of the soccer robot where the camera is mounted right on the robot itself, a basic tracked model, a trail searcher, a tunnel robot, a color detector, an explorer robot, and a rescue robot. Now, let us turn our attention to the curriculum itself. At this point, as we've already established the themes and the concepts the robotic competition set will help you address in the classroom, let's now take a look at how the curriculum itself is structured. Each of the 4 project theme units focused on in the curriculum for the robotic competition set contains a roadmap of sorts where each of the following elements are addressed: the purpose, the concepts, the student deliverables, assessment and evaluation materials, an outline, the standards, an authentic project scenario, a daily teaching plan, supporting activities, and resources. Now, right now, here you'll see the table of contents for the robotic competition set. First thing I would like to note is that the section right at the beginning that I mentioned a couple times previously, which is designed to help new users of the Fischertechnik system to quickly get up to speed. Again, the core building blocks in the Fischertechnik system are designed to attach from all 6 sides, and many of the other parts are designed for very specific design purposes. Now, as this is different than the simple stacking construction that you'll find in other building sets, we've included this section right up front to help increase your comfort as a teacher with the system, and also to allow you and your students to get the most from your building experience. For example, there's a section showing how the parts fit together and discussing the pin and groove assembly method that's used. A section showing you how to identify the different parts from the core blocks to more specialized parts, things like clip axles, girders, rivets, angle pieces, and more. And for those educators who might be new to conducting a class of this type, there is a chapter specifically discussing project-based STEM education. After this introductory section, we have the 4 theme units which I introduced earlier in the presentation. Again, these are competitions, programming, sensing and vision systems, and mobile robotics. In the following slides, I'm going to share some examples from these 4 different theme units to show examples of how they address the structural format as I touched upon a few slides back. First off, the purpose. Each theme unit will start off with a section outlining the purpose of the project to be addressed in that particular unit. Now, this is the section that spells out for students a clear answer to that eternal question, well, why are we doing this? As well as what skills we hope to develop. Now, in the example shown here from the unit on programming, the focus will be on students designing and implementing a program to control an automated system. Now we'll look at the concepts. This is followed by a section which lists the concepts that are going to be addressed in the particular unit. And these can be considered the big ideas that students should learn from this unit that are going to be useful and vital for them to understand and know, not only in completing their current projects, but also things that they're going to draw upon as they move forward in STEM fields of study, and of course, we hope, STEM-related careers. Now, this particular section, which you see on your screen right now, is taken from the unit on competitions. And this provides an overview of some of the areas that students are going to begin and learn about and explore in this particular unit. And this would include things like control statements, linkages, mechanisms, automated systems, sketching, and so on. Next up is the outline, which is found in 3 of the 4 theme units. One doesn't have it. Now, in the outline, it's spelled out more specifically what's going to be covered in that particular unit. Now, the example on the screen right now is taken from the unit again on programming, and so here we'll see things listed such as documenting programs, working with object blocks, Boolean mathematics, loops, branching, data, and so on. After this, we enter the section where each of the specific standards to be met by each particular project unit is spelled out, which of course provides the educational justification for the project that they're going to be doing. Now, we often get asked if our curriculum-based programs meet the standards for a particular state or a particular district. And while, of course, we would love to be able to state that they do, with 50 states and so many more districts in each, being able to clearly align to all of these individual standards, of course, isn't really practical or feasible. So instead, our approach was that what we have done is we've selected the most universally accepted standards that are currently in place in the United States. Again, this means that we have things like the college and career readiness math standards, which are followed by the reading standards for literacy in history and social studies, as well as the writing standards for literacy in history, social studies, science, and technical subjects. After this, we have science standards, beginning with the NSES content standards for K-12, the standards for technological literacy, the ISTE Technology Foundation standards for students. Now, after this, we also have an assessment section with links to both general course rubrics as well as rubrics related to the specific theme of the unit. Following this, we have the essential question. And this can be thought of as the major idea to be explored in this particular unit. Now, in this example, which is taken from the unit focusing on sensing and vision systems, the question being put forth is, how do automated devices sense and interoperate the world around them? The student scenario for each unit gives the students an opportunity to explore that particular unit's essential question. Now, this is done in the form of a real-world problem that they are given to solve, an answer to where will I ever use this? Now, in this particular example, students are told they are part of a technical sales team working for an alarm company. And to quote directly from the scenario, quote, "Your company has been trying to increase sales to the museum alarm manufacturers. The decision has been made that sales could increase if there was a web page created that had a section for each sensor, a description of how it works, and a sample alarm circuit that others could use to base designs from. You will have to build a prototype of the situation your alarm will monitor and list conditions you will monitor. A section on suggested calibration is also necessary. Your team has been charged with this project. Your team will brainstorm what the web page should contain and how it should be laid out. Your team will conduct internet research to discover how sensors work, what other companies do to create data sheets, and how to create simple web pages using Microsoft Office. Once the research is done and the enabling activities are completed, the team will design their sections for the web page. Any software created for the web pages should be documented completely so another team can easily figure out the work you have done. All work should be documented in the engineering notebook. Students will devise alarm circuits utilizing at least 3 methods. Each sensor will have a page in the manual, and sample alarm circuits should explain how each sensor works and sees things the others do not. Students will present their online files along with a presentation of their prototype in hopes of landing a sales contract." End quote. Now, in another such scenario put forth in the programming theme unit, the student groups will be tasked with designing and building an elevator that will need to function in a particular manner, such as how it will respond to a call button being pushed on different floors at the same time. Each student group will be tasked with designing a programming protocol for how the elevator will navigate such occurrences. Now, once again, the fictional client's requirements are clearly spelled out, and the students will be required to create a program to address these specific needs, create a physical prototype using the Fischertechnik components, and prepare a presentation for these clients that includes a demonstration of the prototype and the program in action. Following that, we have the daily plan, which clearly spells out the expectations as students will work through the particular project in the student scenario. Each day of the plan acts as a guideline and spells out specifically what the students are going to look at that day and what everyone was going to need to accomplish. Now, you'll see that as different concepts are addressed, students are provided with helpful links which will give them more information. For example, they will have links showing them what will be required in the design brief we've talked about, or an engineering journal. Once again, each day has a different task to be addressed, a different activity to perform, or a different question that must be answered. In the example now on your screen, again taken from the unit on programming, if you look at the bottom of the page for day 7, there is a discussion topic which is, how does my dishwasher know when the dishes are clean? Which, of course, a dishwasher doesn't know when dishes are clean, but instead it's actually programmed to go through certain cycles for a specific period of time. And so in this scenario, the student can lead the teacher can lead a discussion where this concept can be explored. Now, other things covered in this unit, for example, will include how data is taken from a sensor and recorded, or how files can be taken from the RoboPro software format and put into an Excel format to be worked on, and then placed back into the RoboPro program, and other such things like this. Now, as students work through the daily plan and on their answers to each student scenario, they will be required to perform research, as we said. They're going to do trial and error experimentation, and they're going to document the entire process, which once again means maintaining a design notebook and an engineering journal. Again, they will design and build a working prototype using Fischertechnik, and also create and deliver a presentation of this prototype in action. The curriculum is designed so that each day in the project theme builds on the one before it, and each activity is subsequently more complex, and along the way provides the information that the students are going to need to draw on to successfully complete that given project. What this does is it really helps to reinforce all the concepts for the students, and it ties everything together in a very organic and meaningful manner. There's a section at the end of each unit where various additional materials are collected, and these could include vocabulary words, links to carefully vetted web-based resources, can include Word documents, PDF files, and PowerPoints depending on the unit. Now, once again, each of the 4 project-themed units follow the same structure as what we've just seen, including the standards, the rubrics, the daily plan, the resource materials, links, and so on. And as I mentioned before, there are also numerous links put throughout the curriculum for more specific information on specific topics. And these are all collected in one section at the very end of the robotic competition site curriculum. This includes activity links for sketching, schematic drawings, Ohm's law and power, an introduction to working with the RoboPro programming software, and to becoming familiar with the TXT controller, working with flowcharts, open loop programming, and closed loop programming, digital branching, logic levels and programs and triggering, logic gates, combinational logic, analog branching, variables, data, sensors such as the digital switch, the digital phototransistor, and the digital trail follower, analog sensors such as the NTC resistor, the Photocell LDR, the color sensor, and the ultrasonic distance sensor. An introduction to using the camera attachment, using the camera to detect motion, color detection, using the swiveling camera as a ball finder, learning how to have the robotic models follow a line path, learning how an encoder motor allows for precise control of movements, and building the control panel. And as documenting the entire process is a major focus of the curriculum, there is another section included at the end of the curriculum that spells out the proper procedures for record keeping of this sort. Now, this is designed to help students to develop proper work habits and embeds technical literacy into the projects. For example, the requirements for maintaining an engineering notebook are detailed. The elements that make up the design process are outlined. Examples of design documentation are discussed. The problem statement is explained, including its components, the vision statement, the issue statement, and the method statement. Points to be summarized in a design brief are discussed. The elements of testing protocol are outlined. And finally, the required components for an engineering report are also clearly outlined. And finally, this is followed by a section collecting the step-by-step assembly instructions for each of the 20 models, which, as I mentioned, are also included in a printed version inside of each set. And that's everything you get and everything you can explore with the Fischertechnik robotic competition set. So just to summarize, the Fischertechnik robotic competition set contains everything you need. That means all the parts, the RoboPro programming software, the compact and powerful Robotics TXT controller, the rechargeable AccuSet battery pack and charging unit, all the step-by-step assembly instructions for building 20 different instructional models, and complete and highly detailed day-by-day curriculum. And I would like to state that the curriculum included in each set is yours to use this year, next year, and for many years after that. There are no additional fees, there are no subscription charges. Everything you need is included. Each set, again, is designed for use by teams of 2 to up to 4 students at a time, so it's easily scalable. By that I mean if, let's say, you had a classroom of 20 students, you could use as many as 10 or as few as 5 sets, depending on your particular budget and how quickly you want students to move through the material. And once again, it's all reusable. Build a model, perform the experiments, take it apart, and you're ready to build another. And of course, if you ever did need or want any odd parts, any replacement pieces, you can purchase those individually in whatever quantity you choose or need directly from the Fischertechnik Studica website. And once again, the Fischertechnik robotic competition set is designed to make it easy for educators from any background to offer a hands-on, project-based learning experience to their students. Once again, this is what experts agree is one of the most effective methods known for teaching STEM concepts like robotics. Pricing on this set starts at just $6.99 per set, and of course, quantity pricing for classrooms is available upon request. So at this point, questions. Well, despite what the slide says here, there's really 2 methods to ask a question here, since speaking in real time isn't going to work as well today. You could either type in the Zoom chat window, the group chat window, which once again you can access under the ellipses that you'll see on your screen or toolbar where it says more. If you click on that, chat will be one of the options, and then you can type in any questions you might have. Or if you like, you could also email your questions to me directly. As you'll see, my email address is up there, LanceZ, L-A-N-C-E-Z, at Studica, S-T-U-D-I-C-A.com. So if you want to ask me now, if you want to ask me after, either option will work. I will give everyone a second. Just like an auction, we'll go going once, going twice. And if I don't see anything come up, I will say thank you for attending. So once again, I'd like to thank you for taking the time to attend today's presentation. Now, if you would like to know more about the Fischertechnik robotic competition set or any of our other STEM-related sets, and this includes the Introduction to STEM series for elementary students, the STEM Prep 2.0 and STEM engineering sets, which once again are our other 2 standards-focused project-based curriculum sets from Fischertechnik, or if you would like to know about our line of industrial simulation and training models, any of these things, if you'd like to request a quote, or if you'd like to speak to a dedicated educational representative for your state, you can simply call us at the numbers that you see on the screen right now. If you're located in the United States, our toll-free number is 888-561-7521. Or if you're in Canada, you can reach us at 800-561-7520. Now, you can also find more information on all of our products by visiting our special STEM education page on the Studica website. And the address for that page is shown on your screen. It's www.studica.com/Fischertechnik, Fischertechnik-education. Or you can email us. Our general email address is info@studica.com. Or again, if you have a specific question about what I've discussed today or anything Fischertechnik related, you can also email me directly at LanceZ, L-A-N-C-E-Z, @Studica.com. Once again, thank you very much for attending today. Have a great afternoon.